Watch out.
I'm about to grab the end of this. And that 30,000 volts is not going through me, it's going over me. And you need to hit the lights for them to see this. Let me do that again. Hit them all, yeah.
Start. Let there be light.
Can you help with this one? Grab the end of that. Don't grab the metal part, just grab the tube. Okay? And come on up here. Come around this way. So. Right there. Grace. Okay? And, whoops. The painful part is if it arcs to your finger, but if you grab it quickly, you don't feel that. Okay?
Does the ring
so, actually, let me grab this first, and then you're going to grab about there and show how it glows brighter because you're helping to ground it, okay? Ready? So, I grab the end, I grab this, and now you grab, and it got brighter. Now watch this. I'm letting go. Hold on to it. She's not even touching, and I'm maybe about 30 centimeters, 40 centimeters, good part of a meter away, and it's still, now it went out. Now I come back, it's a different threshold before it goes back on. So then I come back out like this. Fun stuff. Did you even feel anything? Okay. Let's get these balloons taken care of. What do you say? Bing bang boom. I've got 3 balloons here. One is full of pure hydrogen, one is full of pure oxygen, and one is full of a mixture of the two. Any prediction about any of them there? You should be able to make a prediction about one of them. One's pure hydrogen, one's pure oxygen, and one is a mixture. What's that? The blue one is? Oxygen. The pure oxygen. Because it's got to be the most dense of those 3. It's the only one that's dense enough to not be floating. That makes sense. How about between these two? Which one's the pure hydrogen and which one's a mixture?
The red one's more than
How can you tell the red one's a mixture?
the string is not as taut.
Nice. Earlier they were probably equally taut, and I would have done this to give you a little bit more of a, yeah, right? But you saw it just in the tautness of the string. Good for you. Okay? So, we are actually going to try. Let's see what happens when we ignite a balloon of pure hydrogen. Okay? Half off. Okay? So, ready? You might want to cover your ears. Just cup your hands over your ears. Okay? And did I tell you this is pure hydrogen in here, okay? Let me make sure you got that. Whoop. Okay. 3, 2, 1. That was impressive, but it was more of a kind of a poof than it was a loud boom. That wasn't like ear splitting. That's a good thing. Because it was pure hydrogen, it had to mix with the oxygen in the air around it to burn. And that took a few tenths of a second. I don't know, it took some time. This one is pure oxygen, okay? Everyone needs to cover their ears for this one. Pure oxygen. This is what causes everything to burn. Ready? 3, 2, 1. You should have seen that coming. What's oxygen to react with itself? Oxygen supports combustion, but oxygen is not combustible. But everyone needs to cover their ears for real. For real. 3. Cover your ears. Cover your ears. 3, 2, 1. So I got in here 3 other balloons. None of these are combustible. In here, I have helium. Could you do me a favor just, or you got your hands with that? Oh, great. Okay. And in this one, wait a second. Oh, not that one yet. In this one I have air, which is mostly nitrogen, but a little oxygen mixed in. Kind of behaves like an airflow balloon. And this I have a gas that is about as far in the other direction from air as helium is below it. Do you know what the gas is?
Is it sulfur hexafluoride?
It is sulfur hexafluoride. Raise your hands if you've heard of sulfur hexafluoride. Oh, this is great. There are some cool demos you can do. It's the proverbial lead balloon. One demo you can do is to breathe it in. Now, you've all heard the helium voice, right? I do need to tell you this. You're saying, is that safe? Helium is a noble gas. It's totally non-reactive, but at the same time, it's not air. It has no oxygen content. So as long as you're breathing in helium, you're depriving your brain of oxygen. You're saying, well, that's no worse than holding your breath. Yes and no. It's like holding your breath, but when you hold your breath, you have the instinctive reflex to gasp for air. That reflex is not caused by a lack of oxygen getting to the brain. It's caused by the buildup of carbon dioxide that you're not exhaling. It's a buildup of carbon dioxide you don't get rid of, and that's what causes you to gasp. But when you breathe in helium, you breathe out, breathe in helium, breathe out, you have no buildup of carbon dioxide, and you all of a sudden might pass out without any kind of warning. Every time I do this, I get a little bit dizzy. Dizzier than I swear I get if I were just holding my breath that same amount of time. So anyway, the other thing to let you know, to get the full effect, it's not enough just to, you want to intentionally exhale all the air that's in your lungs. And that's not just, it's,
and this is what I found out helium in my voice box is because helium atoms are moving so fast.
it's not, oh, there's the dizziness right there kicking in. It's not a density thing, it's a Graham's law thing. Lighter particles move faster. And you can tell how after taking a few breaths I'm pretty much back to normal because the helium's just leaking out. Right? So one more time, my regular voice.
And my voice on helium, okay? And that's the munchkin you always hear, right?
So, this is air. Wait till you hear this. You have to exhale all the residual air. Hey, it's called a control, an experiment, right? I got to show that breathing in through a balloon doesn't in and of itself cause my voice to get all wonky like that, right? Any predictions?
No, you good, bro.
It's going to be worse than yours.
Prepare to be amazed. I spoke too soon. Okay. So you're thinking to yourself, wait a second. I know the periodic table to know that sulfur hexafluoride is not a noble gas. Sulfur is what spews out of volcanoes. It's what they make matches out of. Fluorine is the most reactive nonmetal on the table. Would I dare breathe in a mixture of those two? Yeah. No! But this is not a mixture, it's a compound. Those two very reactive nonmetals have reacted so tenaciously to each other that this gas is as good as a noble gas. It's inert, good word to know. Okay? So, you ready?
This is what I sound like. Because as I sex molecules are moving so slowly. And even after I take in a breath of air, it still sounds like that because it's sitting down in there like in my lungs like a density gradient. Here's my third lungful of air, and I'm almost kind of back to normal until I get to the bottom of the lungful, and then it gets deep again. And I think now I'm pretty much back to normal. And I'm sorry that what I'm about to do right now is going to give some of you nightmares. But I'm going to give you my sinister laugh. It's going to start with a boomba. Oh, well. Sulfur hexafluoride. Yes. Okay. So many demos to show. I definitely want to show you this though. This is a little bit more subtle, but it certainly is worth it. And I know, I'm glad it's not filled up to the back. The closer you are on this, the better. But I've got just some soapy water here. And soap film demos, there's so many cool things you can do with them. This is just a wire loop. And what soap films are really good at is being as small as possible. So that's a nice little flat surface. You're like, well, that's kind of boring. It is. But what soap films do is they cover an even frame with the least total surface area. Even some crazy frame like this, I can make even crazier here. Okay, how best to cover that frame with the least amount of material? That's actually a mathematical problem that a computer could solve in maybe a week or two. And the soap film does it instantly. That's the best way to cover that frame with the least surface area. Minimal surface areas, that's what it does well. What's that?
What happens if you blow a bubble?
Yeah, you blow a bubble. But some other variations on that. Some of these, by the way, are adapted from a book I read by a guy named C.B. Boyce. This was written back in the 1900s, early 1900s. I added this little rope, but this is a little corkscrew thing. And of course, it shouldn't surprise you that it gives you a nice little spiral slide. But if I then pop half of it, and then I can zip and unzip the remaining film. Every single time, that soap film is showing me how to get by with the least amount of surface area. I will need a dry finger from you just in a second. A slinky shape, a helix. Okay, ready?
looks like a dryer vent. Go ahead and pop right down there with the dry finger. You don't often get a chance to see a soap film receding like that on a frame because it's so fast. But here it was forced to go up that. So we're going to slow that down. We're going to have that in slow motion. You ready? So I'm going to go like this again. But this time I'm going to introduce a bubble there. So now you're going to pop below that. And then, yeah, then get that out of the way so we can see. Whoop.
Oh, wow.
I don't know where my cube went, but I had a whole bunch of other frames to dip in here. But this is by far the trickiest, but also the most rewarding. I don't know if you've seen cubes and other things like that dipped in soapy water. They really are spectacular. Does anyone know what this shape is called? Dodecahedron. It's got 12 sides to it. It's one of the 5 platonic solids. And even though it's a pretty distorted one, if I dip it in and then dip it in again to get a bubble in the middle, I can sometimes get a dodecahedral film in the middle. And you know what I mean?
Keep zooming the camera is about to like start.
Okay, here we go. Oh, there it is. First try. It's got a couple extra bubbles on it. That little gem in the middle there is a much more perfect dodecahedron than the one I actually made out of coffee stirs. And I can't get rid of these other ones there, but isn't that fun? It takes a little practice, but I'll try it one more time here. Oop, we got it. Just gotta get rid of these 2 right there. Okay? And again, all I did then was stick this in and make it a little bit more pronounced, that little guy in the center. Again, these other bubbles kind of get in the way there, but cool stuff. Okay? Okay. So anyone recognize what this used to be? Soda bottle, right? I got some soapy water in there, and the frame you get when you, I know not all of you from St. Louis, but there's a very important building in St. Louis that's shaped like that, and that's the old Science Center, okay? And there's the new Science Center. If I add some air, too much. And then cap it off, I get my 2-liter soda bottle back. This is the hoop. When I take my hand off of it, it wants to economize that film by tightening off in the middle and getting all slimy. Okay? I'm going to try this, but I make no guarantees. I definitely want to take these off. But this is certainly something you can do at home here. Okay? A soap film and a bubble. You want me to blow a bubble? Someone up here did? Oh, shit.
Wait 10 minutes.
The bubble trampoline. Ooh. Okay? Cool stuff. got this balloon too wet to do this, but this one's still my work. This is even more temperamental than the last one. I have here a t-shirt, nice little tie-dye t-shirt, that I really just want to build a static charge in this balloon with. And let me okay, we'll see if I get this to work.
Oh, so close. Oh, you almost got it. Hey, hey. Oh, no.
Wow. I honestly have about 30 more minutes worth of stuff. Is that going to be okay?
Yeah.
You're okay with that? You know, okay. Let's get you taken care of. This is Hannah. She came in right away and wanted, you're going to come over here, Hannah, actually.
Gotta make her warm.
And so you're going to stand on that, but be real careful. And you're actually inside this plastic bag. Okay. Is that too close?
A little bit.
Okay.
This is the push.
Cool. Okay. So you've all seen vacuum packed food? Yeah? Why do they vacuum pack? Why do they vacuum pack food? Like coffee sometimes comes vacuum packed. DiGiorno's pizza vacuum packed because oxygen is food's enemy, right? Makes it go bad. So we're going to vacuum pack Hannah. Look at that, she has no hesitation buttons at all. And so here's what I'm going to have you do. So kind of crouch down on your back against this. The back of it, kind of crouch down, yep. And then just like that, okay? Got it? Okay, not your head, not the head. Okay? Now.
Looking pretty toasty there.
We're using the good old Hoover Porta Power. And here's what you're going to do. I'm going to hand this to you, and you're going to have it like this. And you don't want the bag to get caught in there. And you don't want to put your hand over it. You're going to put your hand like this so it still has room to get around, but the bag's not in there, okay? So, oh no, let me, inside the bag. Oh. Like that. You don't have to worry about the bag. Okay. I'll get the bag. You hold on to that with one hand. I'll get the bag. Oops. Okay. Got it?
Is it like this?
Yes, okay. Perfect. But you don't have it so it's airtight around there, right?
No.
I don't think you'd be able to make it airtight around there. And I'm going to kind of, so everyone see you here? Now I'm torn. I could use a thicker plastic bag, like dark one, but you wouldn't be able to see so well. So here we go. Oh. So hold it in closer to you and let more air get in. Yeah, that hand shouldn't be quite so tight. Ready? So protect it more, something in between what you were just doing the last two times. So one hand over it. There you go. Ready? There it is. Can you raise your arm?
No.
Isn't that a weird feeling? Here's the weird thing about that. Have you ever tried this? You could probably try it on a younger sibling first. Not a pet. That is not good. Not nice. But make sure their head stays out. You feel like you're being crushed.
Yeah.
You feel like you're being squeezed. It's like, wait, what? Huh?
Like a really Bad hug.
Exactly. Where's that hug coming from? It's coming from the atmosphere. We often forget about. Let me plug this in here because we need this inside. We often forget about the air around us, but it's constantly around us, constantly pushing on every square inch of our bodies with like 15 pounds. That's like a bowling ball on every square inch. Well, wait a second. I was taking the air out. How would that? You have an idea?
Negative air pressure?
You're on the right track, yes. You said negative air pressure? Yeah, kind of like that. Right now, your arms, as you sit there, are being pushed into your body with this incredible force, but you don't feel it because there's air between your arms and your body pushing outward. So your arms just kind of hang there, right? They're being pushed both ways. I took this air away, the air between the arm and the body, and then all you felt was your arms essentially hugging you, and it wasn't a pleasant hug, was it? So, cool. I have some styrofoam cups planted. There's one, and there's one. Okay, I've got my work cut out for me. So, this is my air cannon. It's a trash can, to be sure, with just a rubber mat. I've seen these made with shower curtains, by the way, so anything that you can just take over this, and then a hole on the other side. So this is a pretty easy target here, front row. Why don't you stand so everyone can see?
Yes, sir.
So you guys know how effective it is.
You need to see the cannon yet. Come on, girl.
Okay,
Come on, Sam.
This is hard now. This is far away. I'll give it a try. I wish I had actually missed on a couple of those. I always say, oh, I just barely missed. And of course, you can't say what except for people who are behind them and feel it, right? Yeah, what does that little air bullet look like? We're going to find out. I've got a fog machine here. And I mean, talk about a low-budget demo that is maybe the most spectacular one of them all. Not so much chemistry, it has to do with, I'm sure, fluid dynamics and all that. But, so it's ready. And all I'm going to do is... Okay, you ready for this? Yeah. This is magic.
Magic.
Smoke rings?
I got it.
It's a battlefield here.
Yeah, but it's just annoying.
Just like you saw that bubble do that kind of wonky thing, right? I can sometimes get one of these to do that by sending out a slow one and then shooting a fast one past it. That's kind of cool to see this one. Oscillating, undulating, probably a better word to use. So watch for this, I'll give it a try. Here's the slow one.
Can you make one
Hey,
instead of another one? Like shoot slow and then fast?
Are you seeing the one go? Yeah. Okay, cool. Fun stuff, okay? So anyway, I'll shoot a couple more of these over your heads just for fun.
Fan service.
You're so destructive. talk about this fog machine was like $35 on eBay or something like that. Super easy. Okay. Whew. You ready for this demo, I think, yeah? I'm ready for it. So, in these little film canisters, I've got a material called calcium carbide. And this is just water in the speaker here. And I'm going to put, I want to save some of it. Some of it in the water. And you see right away, it forms a gas, and that gas is acetylene, which is flammable. Cool. But not much of an explosion, right?
Uh-oh.
So, these are 2 Gatorade bottles. I've made little holes that I marked so I would find them easily. And a little bit of water in each. And some bandanas, tie-dye bandanas, of course. In one of them, I'm going to put 0.5 grams. 0.5, that's like a tiny little portion, okay? And shove the bandana in there. And that same reaction is taking place in there. This is more of a closed system though, right? In this identical Gatorade bottle with the same amount of water, I'm going to put 5 times as much. 2.5. And shove the bandana down in there. Okay? We want those to completely react. Okay? In the meantime, I'll show you a neat little thing about that. It's actually, there's one on display out in the hallway back there, over by the drinking fountain, between the 2 bathrooms. If you have a bathroom here, take a look. It's a miner's lamp, an old-fashioned one that runs off of calcium carbide. It reacts with water. You actually control on, there's a little lever that controls the drip rate. And that little acetylene gas comes out of this little nozzle, and it lights, there's a little striker to light it, and gives you a bright flame. I don't have a working one. This is actually the mirror to one, right? But I made one of my own, like this. So, here's some water. Here's some more calcium carbide. I'm collecting the acetylene gas in this syringe. Got a little bit of moisture in there, but I don't think that's going to make a difference. Okay? Okay? And so here's a little 50 milliliters or so, 35 milliliters of the acetylene gas, the same bubbles that were there, the same bubbles I'm generating there. And if I just, this is about the size of the opening coming out of that. That is the little bright white light, which if I put a little reflector here. You can go turn lights off on this.
Hallelujah, 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 hallelujah.
Look at how bright, and that's giving off quite a bit of light. If I were a miner, that would be enough to see what I'm doing right in front of me to be sure. Okay? And that's just from a little bit. So we're good. Okay? Okay. Part of that was just a stall to give these time to react. What I have here is one of those, they're called aim flame, barbecue lighters, whatever. They're running out of fuel, but it still has the sparking mechanism. So I stuck a speaker wire down in there, and now it sparks the tip. People in the front row maybe will see a little spark jump across there. Remember I told you there was a little hole in the backside. So, this one could be potentially loud. So, yeah, that's fine. Can you all see it? 3, 2, 1. This one has 5 times as much.
Warning headphone users.
Yeah, for real. In fact, I'm going double protection on this one. Ready? 3, 2, 1. Gotcha. Why, if this had 5 times as much acetylene, yes? It pushed out all the oxygen, it pushed out enough. Yeah, a lot of these have similar morals to them. You need 2 to tango, right? Acetylene and oxygen. So, yes, I go like this and blow in some more, but of course I just blew out a lot of the extra acetylene gas. So, will this go? Maybe. Carbon dioxide, by the way, is not a very big component in our breath. The big story is this: what we breathe in, someone said carbon dioxide. Just so you know, what we breathe in is about 20% oxygen and about 80% nitrogen. There's about 1% of other gases, but what we breathe out, 80% nitrogen, 16% oxygen, and about 4% carbon dioxide. Isn't that weird? We only utilize about 4% of each breath. Okay, let's see if we can get a little noise out of this. Cover your ears. 3, 2, 1. That was nice. Wow. Okay. While we're talking about explosions, this is one you might have seen.
That seems like a lot.
This is a Pringles can. And hello, it tells you, it says loud on the container. These are loud Pringles, okay? They're super cheesy Italian loud Pringles. There are no Pringles in there anymore. They were delicious. And they were loud because I chewed them with my mouth open. Okay, some holes poked around the sides here, and probably more important, a hole right there in the center that I'm covering with some tape. Here is a gas we saw before. This is zinc and HCl, which react to form, let me get the, to form hydrogen gas. And I'm going to put this right here over the top. And you're thinking, wait, won't it just kind of leak out the bottom? Hydrogen, like helium we saw earlier, is less dense than air. In fact, hydrogen used to be used in blimps. I have no idea how long this takes to fill, but I'll trust that's been long enough. Okay? There actually is a way. I'm not seeing the other part of this pipette, so... Oh, there it is. I could try this way. Taking a little sample down here. I hear a little beep. That means we're good to go.
Uh-oh. Sound.
I do want to make sure it's pretty much full of hydrogen, void of air. Okay? So, ready? 3, cover your ears. 3, 2, 1. Ah! Do you see the little flame burning there?
Yeah.
Can we hit the lights? This is my Pringles candle. What just happened?
We got pranked.
That was loud. Okay.
We got pranked.
You might have seen that coming if you thought about why it didn't explode right away. It was pure hydrogen. Pure hydrogen didn't have any oxygen to react with, except out here, where it mixed with the air, the oxygen in the air, and it supported a flame there. But as hydrogen was leaking out through the top hole, what was leaking in through the side holes? Air with oxygen. And when it got to a combustible mixture, the flame could backfire in and kablooey. Another version of that goes to an even older container than a Pringles can. The oldest container, isn't it? Think about that.
Let's make omelets with the rest of them.
Did you ask if it was going to explode? Okay, same idea. I've swapped out my big long tube for that. I might add a little bit more of the HCl. And again, here I'm just going to eyeball how long it takes to fill that egg. Now, while that's happening, I mean, all those bubbles, it shouldn't take long. The very first time I tried this, and this was back in 1987. Wow. They came up with this idea of using an egg for this demo instead of a Pringles can. And I had it on a little tiny little stand. I lit it. Nothing happened, and I reached down, because you saw how hard it was to see the hydrogen flame with the lights on. And as soon as I grabbed it, bam, right there in my hand. So this was a student demo, and this is about maybe 5 years ago. And when I told that story to the students, because we were still putting it down there, they were like, "Oh, can we do that?" I could do what? Can we hold it in our hand and have it go off our hand? I'm going, okay. So that's become my way of doing it now too. So, here we go. And I still have all my fingers to show. So, tape off. It's lit, and you can barely see the flame there. Can you see the flame?
It's gonna explode.
Explode! Explode!
I don't know we got shell shocked on that one. Okay, that was what do we got? We got so much to do. Okay, I'm going in the final. Yeah, we're just going to go right to these. Okay. I've got this one set up, so I'm just going to go ahead and show it.
Why is there a
Same reaction with calcium carbide and water to make acetylene. But this time, instead of the acetylene reacting with oxygen, right, which is what happened in the carbide cannon, the boom, we're going to react it with chlorine gas. Now, chlorine gas is a deadly gas. It's poisonous. It's the first war gas. It's dense. You've all smelled chlorine, which means, you live to tell about it. That in low enough doses, it's not bad. But, I mean, it's put in pools for the same reason. It's toxic. It's a disinfectant. It kills the bacteria. I think I've got this set to generate just a small amount of chlorine when I shake this flask, and then stop when I stop. Okay? By the way, I'll tell you what I'm mixing here, and trust that you will not try this on large scale. It's hydrochloric acid and bleach. I tell you this because when you hear about warnings not to mix certain cleaning ingredients, almost always the problems that result are the fact that one of them was bleach-based and the other one was acid-based. And they react to form chlorine gas, which can cause serious lung damage and death. So, I'm doing it in such small amounts here in a very controlled way, but... Okay? So, it's like a soda right now that if I just give a little swirl, I generate, but I stop, and it stops. What happens when a chlorine bubble hits an acetylene bubble? We're going to want to get lights out on this one too. Okay? Oh, not all out. Hold on. That'll be good right there. Let's see if we can't see that effect. Now lights out.
Scintillating.
It is. I call that underwater fireworks. Okay, lights on. Think how special it is. Bubbles, underwater colliding, their contents mixing, and those two gases reacting with no activation energy needed. No spark needed, right? Cool. Okay. Okay. Home stretch here. Save the best for last. Yes. I've got a trilogy of
Terror.
trilogy of dry ice demos.
Always bring out the full case.
I hope we use the dinosaur. Are we going to use the dinosaur?
What do you think?
Yes. We better use the dinosaur.
We are using.
He sees a dinosaur head up here. This was actually a toy from an old Happy Meal, way back in the day. Lamb Before Time. Yeah. Well, just that was. Okay. Dry ice. That's too big a piece. Okay. Why do they call it dry ice? It doesn't melt. At least not at 1 atmosphere. You have to kick it up to about 5 atmospheres before you actually start to see liquid CO2. Another reason maybe why they call it dry ice is because when you put it in the water, it does not get wet. I would argue that piece of dry ice has not even made contact yet with the water because it's completely surrounded by that envelope of subliming, that's what that's called, CO2. Sublimation. Have you ever thought to add a little bit of dish detergent to this setup?
Is that going to be not
Maybe it just never dawned on you to try it. Okay?
We're not laughing at anything. These are just funny jokes.
They're funny jokes, yes. They are dad jokes, yes.
Happy Father's Day.
Yes, thank you. So this is kind of fun. But one thing, if you look at these bubbles that you really wouldn't expect, if you just watch them for a while, they shrink. A carbon dioxide is a gas that dissolves very well in the water of the soap film. Carbon dioxide dissolving in water is what soda is all about. And here they are dissolving right out of those bubbles and making them shrink. Again, keep your eye on that one big one there on the tip and you'll see it just get smaller and smaller. The bubbles are actually leaking. Okay? So, that's kind of fun. I said I have a trilogy. That means 3.
How many is 3 again?
That's one more than 2, but 1 less than 4.
Is it dripping on the floor? Yeah. The floor looked like it needed cleaning, so I'm okay with that. Okay. We're going to put it. So, this is filled with water to about here, and now there's this layer of, again, this is CO2 that's being mixed with that mist so we can see it. And this is just a wet paper towel that I'm going to draw across the top of it there. Folks, this is too simple. By the way, if you're in St. Louis area, where's the easiest place to get dry ice? Ted Drew's. You can just ask for it. They give it to you free when you get a custard there. So that's kind of fun right there. Oh, and right here, by the way, IV. We don't have IV in St. Louis, but the rest of the state does, I think, so. Isn't that fun?
Will it ever get to the point where it starts?
I'm actually going to put this in there just for fun.
Why Ghostbusters theme?
Okay, lights out on that one. And that definitely gives the appearance of these little explosions of mist beneath it, of a crystal ball. And what I'm doing is I'm just blowing little jets of air to cause it to do that same kind of undulating we saw in the bubble and in the smoke ring. It's like the movie Flubber.
My new favorite word, undulating.
Undulates great. Uno, dos, tres. No, trilogy. Okay. So, these were obviously two separate bottles, but I used two different colored bottles to make that obvious. That one's been cut off high, the other low, so it fits like that. And this is just some PVC pipe. Cool. So let's see what happens. I don't want this to land inside the other one.
Oh, the man. He's really doing it.
So this first one is air from the tube, but then followed by the dense carbon dioxide. And that's a half air, half CO2 and fell kind of fast. This one's pure CO2 and look at how much faster it falls.
Could you hold on to one of those?
I could, but I could also do this. Okay, wait, it's carbon dioxide, folks.
The opposite on fire anyways.
Oh, that one persisted. We can watch it shrink now.
He's just gonna sit there.
A wet hand, you can catch it, and watch that.
Throw it at someone.
It's hard to throw. But do you see it shrinking? Okay. I'm gonna get all these things going at once here. Yeah. Here we go. Again. Got one bounce out of it. Needs to be a dry shirt, I know that.
My high school is the whole.
My high school.
So this is the CO2 shrinking suds, crystal ball, and leaky faucet.
Holy Trinity.
We still have not yet used the dinosaur.
Flappy Bird.
Two liquid nitrogen demos. This is my 3, 2, 1 countdown here. So liquid nitrogen, yes, thank you for obtaining that for me. What I have here, you know what, I'm going to leave that, not just happened when it was in the box, but I'm going to leave that in there. So a stopper, a flask, a tube, let's see what happens. I'm going to pour some liquid nitrogen in here, and there's no way it's all going to go in there. So some of it will end up on the floor. I can't help that. Okay.
I think it'll really help my sore throat if I drink some of that.
We ready? Everyone watching?
Yeah.
Hey, here's the best part. So, I know, isn't that, it's a weird feeling. Be careful though, that's liquid nitrogen, but, so the last time I showed this demo, it might have been here last time, I'm trying to think where it was. I said, this is just fine as long as I'm really careful with it, because, you know, this right now is very brittle. And I set it down real carefully, it just shattered to pieces. So, if that happens, it happens, but fun stuff. Liquid nitrogen.
Hit it with a hammer.
Now, the other liquid nitrogen demo.
Does it require hitting the tube with a hammer?
I've got these bags are both filled with methane gas, natural gas, and they're connected to test tubes that are down in that liquid nitrogen. If you look up the boiling points, same thing as condensing point, liquid methane, methane is much higher, implying then liquid nitrogen is cold enough to condense methane and give us liquid methane. Liquid nitrogen can condense not helium or hydrogen, those are way, you'd be way, way colder. It can condense liquid oxygen. And the liquid oxygen's a cool stuff, it's a pale blue color. But look what happens now. This was about a 4-liter, 1 gallon, 4-liter bag. And the amount of liquid at the very bottom there, about 4 milliliters. There's your 1,000 to 1 change in volume as you go from a gas to a liquid. Okay? And these are both the same thing. So what can you do with liquid methane?
Set it on fire.
Okay. Now, I've seen someone do this, and please make note of this if you ever try this, and made the mistake of and then unstopping and leaving it open, still in the liquid nitrogen. Then liquid oxygen was condensing in there too, and they had a mixture of liquid methane and oxygen, and when they went to light it, it exploded on them. This is just liquid methane, no air can get in there, okay?